Yep, let's get started. I once again welcome you, everybody, into this session. Before we start this session, let me brief about Full Stack Academy. This is an academy which is established last year, December, and with the objective of bringing the gap between the fresh graduates and an IT industry. So we always conduct programs and trainings on the latest trending technologies, which gets jobs for freshers as well as some professionals. So we deeply work on a technology, on a data science, where we have continuous batches running in a data science, which is of 3 months course followed by 2 months of internship as well as a capstone project. So we try to bring the subject matter expert always in the forum, and so that we can bring a lot of awareness about the technology and usability of the technology and its job opportunities in that technology. Earlier, we have also introduced many leaders. Now, this time we have a very great leader with us who is master in data science, Mr. Mirza Rahim Baig Saab. So let me just give an introduction for 2 minutes. So Mr. Mirza Rahim Baig is have done a master's degree in data science from Liverpool John Moores University, and before to that he has done a bachelor in engineering honors with electronics and instrumentation stream from Birla Institute of Technology and Science. He achieved an advanced analytics certificate from International School of Engineering in Data Science, and he is a part-time visiting professor in SVKM's Narsi Monji Institute of Management Studies. He has over 8 years of experience in the data science. Above all, he is an author for a book, and which is very famously and available right now in Amazon, the Deep Learning Workshop, which is exclusively prepared in the content with respect to data science and artificial intelligence. Currently, Mr. Mirza Rahim Beg is serving with a Flipkart in Bangalore as an analytics team, and also he delivers the lectures. He is an author, he is a speaker on the technology, on the subject data science. So with this few words of introduction, I would like now to invite Mr. Rahim Beg to take over this session and start this session on data science and modern data scientist. Thank you very much for listening to me. Over to you, Rahim Saab.
Thank you very much, Ijaz, for the introduction, and good evening, everyone. I hope I'm clearly audible to all of you. You are right? Am I right?
Yes, audible now. Crystal clear.
Perfect. All right. Yeah. Then thank you for the introductions. I'll be very brief. First of all, I'll welcome you all to this session, and I'll talk of the intent behind this session. Right. What we are going to talk about in this session, whatever I think 40 minutes or 1 hour that we discussed today. What we're going to do in that session, and what the overall agenda is. Right. So I'll just start presenting right now. So this is what the agenda is. First, again, after Ijaz's introduction, I'll do a brief intro of myself as well. Then we'll talk of, so we're talking of data science, right? The data science as a field, and we're talking of the applications. And we also want to talk about very relevant, what data science is and what a modern data scientist is, right? So somewhere, right, we believe that there is a bigger picture we need to see. Okay, so first I start off with the what I think is the big picture view of data science. Instead of going into very fine details to begin, we'll go in the big picture. Then we'll talk of what data science really is. We'll take a high level view of this. We'll then look at the different applications of data science, right, and across industries as well. Then we'll address some very common myths around data science, which are very prevalent right now. A lot of noise, really. We just want to clarify all that. And we also want to talk of what the modern data scientist is, what key strengths are, talk of the roles in data science, and also talk of the skills in data science. I understand that many in the audience would be in a state where you are really exploring. Either you are thinking about making a move towards data science, or you are already trying to get into data science, or some of you are already in, maybe, right? Maybe you are a practitioner already, and maybe you just helps get a perspective from someone who has been there for a while. So those are the things we'll discuss. And one second, I'll request you all to go on mute, whoever is not speaking, which is except me, everyone to go on mute.
Yep, I think I have one point before this
Mhm.
one. A quick update. This session is designed a 40-minute session, and if at all, if abruptly this session is closing in 40 minutes, kindly rejoin with the same link. Within the next minute, we will resume this session and continue the discussion. Thank you very much.
Sure. All right. Right then. So with that, I will start, everyone. And of course, before I start, I want that, I think we have some, 30 folks, 30 plus folks. Please feel free to ask your questions whenever you have the questions. I may not be replying to them right away, but if they're there in the chat, periodically, once in a while, wherever there's a logical stop, I will stop and I will try to address all your queries. All right. So let's begin. So first, about my introduction. So Ijaz has already given an introduction, but I just wanted some minor corrections here and there actually. So, and I also want to talk of my entire journey, because I think for this group, it will be very relevant why I'm talking of this entire journey as well. So I started as a, as an applications engineer in a semiconductor company. So I did my electronics engineering from BITS Pilani. I joined a core company. It was a semiconductor company. I was an application engineer. I was writing software for embedded, I mean, not software, but I was writing programs for system on chip, embedded programming, and so on. And it was good. It was like a dream job in the beginning, right? Everybody wants to get into a good core company. But very soon I realized I don't really want to be there. It's not really meant for me. Okay? This was 2009. Towards the end of 2009, early 2010, right? That's when I decided that it's not really what I want to do for life. I don't see myself doing this, right? So I wanted to go to a place where I could use my problem solving skills. I felt that my problem solving skills are good. That's what I felt. And I wanted to use them, right? Work on different kind of problems and so on. So I joined a company named ZS Associates in 2010, right? Now, this company was sales and marketing consulting for pharmaceutical clients. It's a consulting company, and I was what is called an analytics associate. So I was working with data consulting, of course, but of course, database analytical consulting. Right? That's what my role was. That's when I really got interested. I began to see how data really can be used to drive decisions. Data can be used to make the right business calls, and can lead to tremendous amount of profitability. And that's where I realized the power of data. Even the right kind of data visual in the right meeting can lead to a lot of impact. Okay? That's when I realized the power of data. And I've decided for myself that I need to really, this is something I like. This is something I could do for a long time. So then I worked in ZS for for 2.5 years. Then I joined a company by the name IQVIA. This is again a big name in the consulting space for pharma. And here I worked on a lot of data science related, a lot of predictive modeling stuff, a lot of text handling and so on for many markets across the world. So Europe, UAE, and USA and whatnot, right? So a lot of different markets. And again, I got plenty of exposure to data science in general. And this was in the pharma domain. So I felt, I want to be in a little more, say, a fast-paced environment, learn a little more, and a different kind of a domain where I learn more. So I joined Flipkart. This was 2015. A few days back, I've completed my 5 years at Flipkart as well. So Flipkart, I joined in a senior analytics position, where this was all about solving business problems. Okay, this was about using data, using your analytics skills, advanced analytics, build a model. Sometimes it's about doing some quick analysis and so on. Whatever it is, you just solve problems for business. Drive business decision making through data. That's the key. That's how I describe my role really. And in the team, I worked on different aspects of data in retail, right? You have buying, you have selling, you have customer, you have marketing, and so on. So I got a chance to work on a lot of things. Then 2017, I started working with full on in text. So this is reviews and ratings and questions user ask on the platform, right? And again, this is where I really got to implement a lot of newer solutions, the cutting edge things, right? 2017, whatever they were, word embeddings and recurrent neural networks and whatnot. In 2020, finally, I felt that, okay, I have enough perspective. I have learned enough to maybe start sharing, writing about it. I started writing blogs and whatnot. It got noticed, and I finally had my first book on deep learning. So this is essentially a hands-on book. This book is not meant to be theoretical. This book is not meant to be all math. This book is something which is a deep learning, a very hands-on approach. It's called a workshop. So, and the way it works is, anyone, right, without a lot of knowledge, without a lot of math, they can start. A lot of hands-on instructions, intuition is given, then hands-on and so on. This book, and now again, I'm at Flipkart. I'm continuing at Flipkart, of course. I'm working in pricing team where I'm making solutions for uh, pricing at Flipkart, right? How do you price a product? Is it a good price? Is it a bad price? How does the pricing impact the customer behavior and so on? These are the kind of things I've been working on using data science, right? And also, I'm also working on my second book right now, which should be out not too far away. So this is the journey, and why am I mentioning this journey? Okay, one of the things you'd notice in the journey is that started off as an electronics engineer, and I was in a core role. It wasn't. I didn't have a computer science background. I did not start at in a data scientist kind of a role. Even now, by the way, my role is not data scientist as such, but I'll come to that part separately. But started off as an electronics engineer in a core company, and now I'm in a position where hopefully, at least I feel I'm learning a lot. I'm doing much, right, and I'm here, right, talking to people and so on, right, and where I've learned enough to maybe start building my own perspective and things. It's a long journey, of course. I'll keep on learning, but yeah, I've reached some milestones here. And the point is that you don't have to be a computer science person. You don't have to be really a PhD person and so on. You can still really do data science if you just get certain things. And that certain thing is that data science is all about solving problems. Okay, so this should serve as some bit of motivation for everyone, especially those who have concerns about not having an excellent computer science degree and not having a PhD and so on. Okay, I don't have any of them. Okay, right? So that's one. And also, you can make your own journey. If you see, I gradually moved into this whole say more advanced stuff, right? Started off as a consulting kind of a role. Then it was still consulting, but a little more towards modeling. Then I come in a place where there is business. There is a lot of freedom. You do whatever you want, the hands-on model, sometimes no model, sometimes whatever, right? And then finally, I'm in a place where I can do what, I'm in a place where I know now what needs to be done in what situation. Okay? So that's the journey as well. It didn't start as beginning to write deep learning code or whatever. It is a gradual journey. So these are two main things I want you to just remember about the journey as well. Hopefully it is relatable as well. Right now, with that, right, but I've told data science, and I've been talking about, anyone can do data science and so on. So what is data science? Let's take a moment to really all together come to a common understanding of what data science is. Right? Because I understand that right now there's a lot of hype. I wouldn't say just hype. Hype is justified, I believe, but a lot of confusion about what data science really means. Different people are referring to it differently. Different people think of it differently, and so on. And if you, let's say, tried to understand what data science is somewhere, let's say on the web, you will come across these Venn diagrams. Okay, saying that data science is at the intersection of machine learning and statistics, and there is computer science, there is, let's say, I don't know, numerical methods and cloud and so on. And very soon you get into these very complicated Venn diagrams or whatever, some other diagrams and so on. And this is a problem, right? This kind of a view is not good. even those who are a bit enthusiastic about this, who want to try this out, and you see this kind of view, first of all, you get confused. What is this even? Even if, let's say, you put a lot of effort to understand this, it is deterring. It gives you the impression that, maybe there's something else altogether, which is beyond your reach. So this is not the view we will look at. Okay. Instead of going by these diagrams and theoretical definitions, let's take a let's take a step back and let's take a big picture view. Okay. And to get to the big picture, first, let's look at this view in front of you right now. This is the internet minute. Okay. The internet minute, this is what happens in 1 minute on the internet. This is, I think, as of 2019, but the numbers now are updated, will be even bigger, of course, but this is what happens in 60 seconds. You see that within 60 seconds, there are 3.7 million search queries on Google as text. There are 375,000 apps downloaded on the Play Store and the Apple Store. There are 38 million messages in WhatsApp. There are 187 million emails sent. Right? Then there are 481,000 tweets. There is close to $1 million spent online on shopping, 2.5 million snaps, 25,000 GIFs, and so on. Right? So what do you gather from this kind of view? Right? What you see this view here, 60 seconds. This is the kind of stuff that is happening. What do you gather from this from this internet minute picture right now? Yeah, please write on chat. And please send your responses on chat. It'll be good to have all of you responding. Right. So, okay, one response is data. Yeah. By data, what do you mean? Are you saying there's lots of data? Is that what you mean? Yep. Okay. So yeah, I think one thing is very coming out very, very strongly, that there is a lot of data. Right? Huge data. It just 187 million emails in 60 seconds. Think about an hour, think about a day, think about a year, think about 10 years. Right? So definitely there's a lot of data. Sami says opportunity. Yes, definitely opportunity. I'll come to that as well. Numerous data, information about people's needs. Yes. So here's another good point. People's needs, right? You kind of seeing where people are doing a lot of activity, and what's going on, right? And how people are behaving in general. What else about the data itself? What do you see about the data, the nature of data? Can you just take a shot at what kind of data is being generated, or what is the nature of data? Just some hint, right? If you see something like YouTube, it is all videos being watched, right? What about say emails? That is all text, right? Emails are all text. Then you have snaps, you have GIFs, right? Numbers, text, videos, location, and so on, right? So one other thing to notice here is that the nature of data. Yes, so Kalantar, you're perfectly right. The nature of data, we seem to have a lot of what is called unstructured data. So what is unstructured and structured? The definitions are, for later. But structured essentially is, data which is given a very fixed pattern, right? Very set, row number, column number, or whatever, right? Like you have in Excel tables, or like you make tables with your hand. Those are like structured data. When you talk of text doesn't really have a structure, right? I mean, there's a free text, like you can write whatever you want to write over here. You have videos also not structured data, right? So there's a lot of unstructured data, and that is one key learning. And not only is the volume of data huge, the nature of data is changing. It is not at all structured, like or not at all structured or convenient, like it probably used to be some time back. Even 10 years back, the way even not even like 7 years back, when I was working with data, the way I was handling text data 7 years back in my previous organization is completely different from the way I'm handling it right now in my current organization. So It does change. Okay, that is one. So two takeaways: huge data, a lot of variety of data, and like someone mentioned somewhere, there is opportunity. Okay, and opportunity for whom? Opportunity for what? So there is plenty of opportunity for businesses, and that also means there is plenty of opportunity for people like you and me to harness the power of this data and create value, right? So that's what I want to. That's a big picture I want to give you. We have 5 minutes, so before 5 minutes, I'll just give you a couple of more slides, and then we'll have to reconvene. Okay. Okay. So what is the big picture? The big picture is that there is huge information. There is plenty of information. We are drowning in information. And I forgot the name of the person, which is why I couldn't source it, but we are starving for knowledge. So there is a lot of information. There is heaps of it. Traditionally, if you had, let's say, all the information was a small table, you could have just gone through the table, maybe did some basic analysis using some software like in Microsoft Excel and done. But now, the volume of data, the nature of data, it has evolved so much. It has become so much unstructured now that we are now uh, finding ways to harness this, finding ways to really derive some insights from it, maybe action from it, learn from it, and so on. And on similar lines, it is said that data is the new oil. Data is the new oil. What do you mean by that? You mean that there is so much power. If a company can get hands on data, and if company can get say insights from data, action on data, there is tremendous value which can be generated. Okay, gone are the days where it was purely gut instinct which used to decision making. Most companies, if not all companies, now want to be or are trying to be data driven companies, if not say data informed, right? That's what they want to be. So everybody is looking towards data for decision making. And the whole point now essentially comes down to this: in this age of data overload, if you can understand data and if you can extract meaningful actionable insights from which business can benefit, then you will be valued. Okay, that's the larger point. All right. So the point is, if you can extract information, or if you can work with, or if you can give some insights from all of this mess of data and the volume of data, then you will be valued regardless of the role you're talking about, regardless of the title you have, and so on. So if there's one point I want you all to take away from this entire discussion today, is this: give value to business and you will be valued, right? That's it. That is the key point. Roles, what skills, all of that are details, but this is the key idea that I want to stick with everyone, right? So now we come to defining data science. And once we get the overall picture, we come to defining data science. Definition of data science. Again, this is not from any random blog or some random person. This is more of a definition from the Journal of Data Science. And definition of data science is almost everything that has something to do with data, which is collecting data, analyzing data, modeling data, getting insights from data, maybe visualizing, presenting, and so on. Yet the most important part is the application in which you're using data to get some insight or do some actionability. That is data science. So unfortunately, now when you talk of data, think of data science, the only thing which comes to your mind is someone building some very sophisticated, very complicated model using some linear algebra or something, calculus or whatever, right? That is the notion I want to dispel. That is a very limited, that is in fact a very, very wrong and very, very limited view of data science. Data science, like you have on the screen, is anything to do with data science, with data and creating value. So if I have to summarize this in my own perspective is that data science is the art and science of using data to solve business problems and create impact. This is very, very important. You have to solve business problems to create impact. Data science is not about making a model just for the heck of it. Okay? So this is it. Now we have less than a minute remaining, so the session may end abruptly any moment now. But if it does, please use the same link to rejoin, and I'll rejoin as well, and we'll continue discussion from there.
Can you just repeat the previous sentence? Art or and science of data to solve.
Yeah, it is you guys can see my screen, right? All of you.
Yeah, we can able to see your screen.
Sure. Yeah. So data science, I mentioned just before we leave, is the art and science of using data to solve business problems and create impact. That's how I would define data science. So now we talked of what data science is, and it's about using data, right? We're talking of solving problems, and these could be any kind of problems. It could be some model, or it could be some good visual analysis, or it could be some recommendation. There's a lot of ways you can solve the business problems. It doesn't have to be a model. Okay, it's a very limited view. If someone says data science is about modeling, there's far more than that. Okay, so now let's come to this small quiz of sorts. Not quiz, but yeah, just think about this. So in terms of applications of data science, so where do you think data science can be applied? And essentially wherever data can be used, right? So can you think of this, did data science touch any aspect of your life today? So think of from the entire day today itself, okay, even in the past 2 hours, right? In the entire day, all the things you've done so far, right? Interacted with the phone or whatever, or the apps and so on. Can you think of instances where somewhere behind the scenes or data science was being used in some of the other situation? You give me some examples of where data science is being used. I'm sure you'll think of many, but yeah, let's have them coming. Okay, so Sami says ads on the phone or the laptop, or say advertising in television. It's a very good example. Sami, that is a very, very big application of data science, where it has a very straightforward impact on the revenues of business, right? Ad revenue, the businesses of things. Ismail says Netflix or YouTube recommendations. Definitely. This is again a big use case. Recommendations on Netflix and YouTube both are serious businesses. YouTube recommendation engines and Netflix recommendation engines have increased the time you spend on the platform significantly, and therefore the ads you watch, and therefore the money you make for these platforms significantly. Okay. Muhammad Ali Sayed says Google search. Yes, search. Any sort of search really is again a very, very big application. We probably don't understand, but the impact of Google search, the recommendation or the results, the relevance of the results. And Google needs to understand your search query. It should process all the data. It should give you back the result in a fraction of a second. Okay. And not just that, it also will give you recommended advertisements for the same thing. It will also rank different, let's say, websites and so on. There's a lot of stuff which Google does. So when you type certain text in the Google search bar, what it means, if Google needs to understand that, find relevant thing, give you back, give ads and so on. There's a lot which goes behind the scenes in a fraction of a second. Okay. Sami says more specific information on SEO and how much exactly is target customers. SEO, yeah. So search engine optimization. So not everybody may know this term very well, but yeah, SEO in general, SEO marketing, all of these are very, very big consumers of data science. What else, guys? Did anyone use something, any of a news app, or something like in shorts, or some sort of a summarized say view of news? So there are applications which will summarize long, say, a lot of text for you. There's a big, let's say, news article of 2000 words. What you see is a summarized version with 50 words. So there is again data science being used over there, right? There's a lot really going on. If you go to Facebook friend recommendations, I'm not sure if many of you are aware that on Instagram, when you use filters, Instagram filters are using data science in the background. Many of these models are on your phone. Okay. Then there is, okay, getting through the research under development beta versions. Yes. Okay, this is another good example. So Sami, the example Sami gives is of research under development beta versions and whatnot, which he's talking about product analytics or improving the product or customer experience through using data science. Okay, using what works, what doesn't work. Should we launch this feature? Should we improve this feature? Is this broken? Is not broken? And so on. It's a very, very big application. Okay, you could go on and on. Really, really, there's no end to this. From identifying potential loan defaulters in banking to say your intelligent filters on Instagram, to maybe your friend recommendations or connection recommendations on LinkedIn, and so on. Right? There's everywhere. The applications of data science are everywhere. In fact, it is very hard to now figure out places where data science is not being used. It is pretty much everywhere. Okay, so no one in this modern day can really claim to be not touched by data science. It is just everywhere. Right now, the Zoom platform is using data science to optimize the experience for all of us. Zoom developed their application based on data science. There's a lot of data science going on really at any given moment. Okay, it's just everywhere. So the first, so far, whatever we've been saying is data is tremendous. Data is everywhere. Data science is about getting value from data, and data science is practically everywhere. It is across domains. It is not like data science does not talk of one, is not used in, let's say, healthcare. It is used in only banking. It is just everywhere. There's a comment by Sami: national security is consuming lots of international budget, cybersecurity, hackers. Yeah, Sami has given more examples. It's practically everywhere, really. PUBG, okay, possibly. Yeah, I'm not into gaming too much, but I know that things like EA Sports and Sony, right? They are using data science to not only change or understand gameplay metrics, but also using things like say their own websites, their own platforms, their own streaming, all of this they are also updating using data science. Abidunisa Begum says Xbox Connect uses for yes, Xbox would need to use. I think Xbox Connect, all your phones and everything, all of these would need this, right? And not just that. I mean, all of these gaming systems have gaming. Let's say companies have their own websites. They have their apps, right? They have their platform. All of that needs data science to be improved. Okay, so I hope this clarifies that it is everywhere. There is no place where data science is not being used. Okay? Now we come to this applications. So we touched upon some applications which were more, let's say, fun applications. But let's now talk of other applications, and this will give you a sense of the kind of application. First, retail. Retail, let's say, DMart near your house, or you can think of retail in terms of Flipkarts and Amazons, even e-retail or e-commerce, right? So can you think of some examples of how e-commerce or e-retail will use data science, or where do you think data will be useful for these people? Whatever you guys are aware of. Any examples? E-commerce. How do you think Flipkart and Amazon benefit from this? Aha, recommendations. Okay, two of you say recommendations. Yes, recommendation is definitely a good use case, good application of it. Yeah, other than that, pattern. I don't understand what pattern really. Pricing. Yes, Ismail. Pricing is a very big one. In my intro slide, I was talking of a couple of areas, right? You can just repeat them over here. Okay. Okay, patterns. Sami says patterns based on time of the year, festival, buying patterns. Yes, good, definitely good use case. Saifullah says reviews for buyers. Yes, again, right? Reviews. So you see, right? You already are getting there. You already are seeing that there's a lot of stuff, a lot of situations where this can be used. In pricing has already been mentioned. This is about what should be the right price, which should for the it should be profitable for the company. It should be attractive to the customer, and so on. Right? Then product recommendation, which many of you have mentioned, which is about if you have bought this, what else you may be able to buy, or what else would you recommend to the customers to buy. Then you have reviews. Yep. And then there is Faisal mentions ads. Yes, Faisal, ads related to searches. Search is a very big application over here as well. Okay, based on what you search, right, they should identify what you're really searching for. show you top results and everything, and also power ads accordingly. Then there is customer engagement. What does customer engagement mean? Customer engagement means what you really want is that your customers come back to your app again and again, right? Buy as much as they can, and when they are on the app, their whole experience should be very smooth. It should not be a problematic or a cumbersome experience. It should be very smooth, right? They should be able to find whatever they want very quickly. They should be able to buy things without a lot of friction very quickly. That's what we mean by this whole customer engagement. Okay? So that is again using data science. Demand forecasting is a very, very important one, people. This is based on, I think someone was talking of this festival season and time of the year and so on. That's where these patterns are really used. Based on the past patterns, past few days, and whatever of the next few days, how much demand for a particular product do you expect? And depending on that, depending on the expected demand, the company like Flipkart will have to get all the goods. They have to stock it. They have to put it in the right warehouses, right? It should not go out of stock in 2 minutes if the company wants to plan to sell it for a long time, right? So all of those things, all of those things are again based on data science. Marketing, someone mentioned ads. So ads, marketing, all those things. Supply chain optimization. This is again very important. How many packages from which warehouse to which warehouse, where it should be stored, and their transportation and cost and volume and everything. A lot of stuff. Really, retail is very, very big consumption. Campaign subscription. Muhammad Ali Syed says yes, campaign subscription as well. So general marketing is a very, very big say adopter of data science. Right. Some examples from retail. Now healthcare. I'll just give some examples myself. Many of you would be probably wearing some sort of a fitness tracker also, maybe. So you have a Gochi or MI band or a Fitbit or some even Apple watches and so on, right? So all of these have these fitness trackers, sensors, information, some other information you enter, right? All of them. Faisal says Arogya Setu app. Yes, that also is qualifies. I think qualifies for being a healthcare app. Yeah. So that is one use case. And we have survival, say for a patient in the hospitals, based on the different parameters of health, the different measurements. They also have survival propensity, which is about what is the chances of the patient surviving. Okay, that's again all quantified. Then of course you have diagnosis tests, right? Tests, data science based on these parameters. What are the chances the person has? Let's say this disease, based on, let's say, and some of you may be aware, right? Based on the X-ray, whether the person has lung cancer or not, and many things really. Then again, another one is optimization in the sense of scheduling operations. So hospital may have only, let's say, 5 operation theaters, right? Only five operations can be done at a given time. But you need to make sure the demand is met. You need to take care of the time availability of the different say physicians, or let's say surgeons, or whoever will operate, right? Of the doctors, of the patient's conditions, everything, the duration it takes for the operation, and so on. So many things. And that's another application, right? Then travel. So you have many again things like personalization. So depending on what the company understands about you, let's say you are a regular customer on Make My Trip, and you've been buying either tickets for flights or whatever it is, right? Or you're going for vacations. Once Make My Trip understands who you are as a customer, they will recommend things to you. They will give offers for you. They will send you email communications or push notifications on your phone accordingly, and so on. Likewise, we have already touched upon the marketing part of it. Emails and notifications and ads and everything come in the marketing bucket. If they understand you, they do this marketing better. And of course, there is search. They need to understand your search query. There's recommendations. There is customer profiling. Right? Again, these applications, you can just go on and on about these. Okay? And finally, banking. In banking, you have, again, a big list. Forecasting, which is forecasting about, banks give forecast about macroeconomic indicators, which is things like what is the GDP going to be, what is the growth rate being like, and so on, interest rates and whatnot. They have to do fraud detection, whether this transaction is an authentic transaction from the authentic customer, or this is fraud, right? Then there are marketing campaigns they do. They estimate customer value. They also have, by the way, recommendation saying that for this customer, if he already has, let's say, say some sort of a city privilege card, I can give him the airline miles card or something. That's all. Okay? And customer segmentation, which is about saying, I have broadly these kind of customers and this is what the customer wants. Okay? So some sort of a grouping of customers. There's a lot of applications really of data science, guys, and I think if the more time we spend, the more we realize this is there in practically every single domain out there. Right? So now, so we have talked of this. We talked of this whole data science, and we talked of it is used to solve problems. But I briefly want to touch upon a general framework of how business problems are solved using data. And the reason I'm mentioning this, okay, the reason I want to talk through the next 2-3 minutes on this slide is to give you an overall idea, which is often missing, especially from those who are not in the industry, right? The notion I want you to understand is or what I want you to really appreciate is all the work that goes into solving a business problem. And with this, you'll understand that it is the model part or the solution part is just a very, very small bit. I want to bring in front of you the considerations or the whole process of things. Okay. So first, solving a business problems, first, it starts with understanding the problem deeply. Okay. It is about spending time talking to people, understanding the specific aspects of the business. Only after you understand all of these things very well, will you have an understanding of what the problem really is. So for example, if a company says, let's say something like a Make My Trip says, my revenue is going down. Okay, my revenue from Make My Trip platform is going down. Now, or maybe let's say they say revenue is going down. Right now, that is a very big problem statement, right? How do you solve it? Revenue is going down. There could be 50 things going wrong for you. So first step you really need to do before you even think of solving it is, where is the problem? What is really happening? Where is the revenue? So you start looking at things. You start talking to people. People have been looking at these numbers. Someone says that the revenue is down. My overall traffic to the platform or overall visitors to the platform is still the same. Revenue is still going down. Okay. So maybe customers coming is not a problem. Then you look at some other metrics. You look at cancellations. Cancellations are not really going up. So something else is going on. You realize less people are now buying things from you. Okay, people are coming, but they're not buying enough. And what you realize now, somewhere maybe you talk to people, you realize that okay, your ads are also fine. So ads revenue is also fine. So there's 20 things which will you go through. Then somewhere you come down, you talk to people, and you realize that okay, looks like what is happening is that once someone comes to my search results page, okay, after you search for, let's say, hotels in Agra, once they come to the results page, after that they're not clicking on the hotels. So even getting to this point that people are not clicking on the hotels, it may take a while. It is not an obvious thing. It may take sometimes even a couple of weeks or even a month to get to this understanding, to isolate where the problem is. Right? So that is the first part. You have to build a solid understanding. Only then can you even start thinking about solving it. Okay. Next, once you have a fair sense of understanding, you start gathering data and exploring data. So by now you have some sense, you have some hypothesis that, okay, this is what seems to be the problem here. People are not clicking, people are not going ahead and so on, but you want more data. Because you want to solve the problem, you have to understand even better, right? So you want to understand, is this happening in the entire country, or is it happening for hotels, let's say in the north zone or the south zone or the east or the west zone? Is it happening for all hotels, or is it happening for 5-star hotels versus 3-star hotels? Is it happening for resorts versus, let's say, business hotels, right? Or is it happening for, let's say, family travelers? Is it happening for business travelers? So many things you may want to explore. After doing all of this, gathering plenty of data, after looking at data in so many different ways, you have your own hypothesis in your mind. Maybe this is wrong, maybe that is wrong. You do a lot of exploration, and then that point you say that, okay, now after spending a month or sometimes even longer or sometimes much shorter also, but yeah, it can take anywhere between a few weeks to a month as well. Okay, 2 days, 2 months. Then you will say, okay, now I have enough understanding to now think of solving it. Okay, remember, we didn't start with a model. We started with this. What is the problem? Now you try to understand exactly what is happening, where things are breaking. Now, after you've understood this, after spending a lot of time, then you try to now create a solution from the data. Now, this solution from data is not necessarily some sort of a deep learning model or a statistical model. No, it doesn't have to be that way. Maybe I analyze the data in this hotel example. I analyze the data. I realize that, what is happening is, for your 2-star or maybe for your 5-star hotels, right? 5-star hotels, for them, people are not buying them enough. And you looked further, you realize that this is happening for certain areas. Okay. And once you examine all of those things, you just notice that all of this is happening for a certain kind of uh, chain of hotels where they probably had some payment thing or something, right? Some offer is not being matching or something. And just that information is enough that, you just fix this payment issue with the hotel and done. Or maybe a hotel a payment issue, or maybe some offer issue, right? Maybe some voucher or whatever it is, right? Maybe some issues, some small thing is broken. You identify that, you tell it to the business fixes, and next day it is done. Why will you build a model for this? You already know the solution, right? You just act on it. So whereas in some other situation, maybe it is requiring a model. Maybe, it is about maybe recommending better hotels to customers. So maybe you talk of a recommender system or a model which recommends things better. But the key point is, it is not building a model. Model is one small part in this entire framework. And this comes after a lot of analysis, a lot of understanding before. Okay, the step number 3 is not step number 1. And often is a small step. Now, once you build a model or build a solution or whatever, you want to validate. You want to understand, you want to be convinced yourself, first of all, and then you want to convince other people, the business or the head of your team or the head of or the vice president, that, my model I've built is very useful. If you use the model, the company will benefit. You have to validate that. You have to convince people. You have to be convinced yourself. So how do you do that, right? That itself is another exercise. Finally, once everybody is agreeing that, there was a problem, yes, Rahim, you made an excellent solution. Now is the time to actually use it, try it out, right? Now is the time to maybe start recommending people based on this. Now is the time to maybe act on the analysis. This is the last part, right? Where you use a solution, you keep on monitoring. I'm using a recommendation system, I'll be running it. Every month you check, is my model still good? Is my model still good? Is my model still good? The moment you realize, okay, model is not doing good, you update the model. Okay. So this is the overall picture, where the key things I want you all to really understand is that there is a whole process. You start with understanding the problem, start with gathering the data. Then after a lot of time spent on that, then you come to the solution, which may or may not be a model. And after the solution is made, you validate. You have to be convinced and convince others that it is a useful thing. And then you implement or you act on it. Okay. So this is the overall view, and model is just one small part of it. Any questions? Anything, guys? No? All right. So this is the kind of view which is typically missing from many, which is why I talk about a deployment. Okay. So Muhammad Ali says about deployment. Okay. So I'll just briefly talk about deployment. Deployment here, what I mean over here is a very general term I've used, but it does not mean that deployment means that, it is available on some prediction service or some API or something. What I mean over here is just using the solution. Using solution, like I said, it could just be that, you made a great pivot table in Excel, okay, or you just made a great graph, and using the graph, you told business that you need to maybe change your return policy in this particular location. That is deployment. People are acting on it. Or it could be something else. It could be a product solution altogether. It could be a software which you have built. It could be a product you have built, right? If that is the situation, then you have built a separate product in a way, which has its own life cycle, which has its own maintenance and so on. Okay. Sami says a patch or upgrade or process improve. Yes, there could be many things which could be involved. Yeah, maybe there is an existing product in which you just update, let's say, how the ranking happens, or a small portion of the entire product is changed. or some backend or some new API is used. Okay, there's a lot of things which you can do. A lot of this is a whole area by itself, right? Right. So I think moving on. Yeah, moving on. So with that, right, once you've understood what this whole problem solving is, what data science is, now I'm very sure at least some of you, right, have read about what data scientist is and what the data scientist needs to do. Okay, and can you tell me of some of the things you have heard about what data scientists must know or must do? What skills do you think data scientist needs? Anyone on chat? What skills do you think data scientist needs? Just in fact, don't try to be right. You just tell me whatever you have come across. No, I'm sure you must have seen, read online, you must have seen some job posting on Naukri or LinkedIn or something, right? Or maybe you just have, I'm sure there's many things you have heard about data science. What data scientist needs? Okay, it's good. Many of you are saying analytical skills, problem solving skills. Many of you are saying programming language like Python, probability, basic. Yes, all of you good. What else? Machine learning. Yes. Okay. So I'll tell you. Okay, I'll tell you. For the past few months, right, I've been observing the kind of job postings which are being there on LinkedIn and so on. And in fact, of late, people are talking about this. Many people are talking about this. Okay, that it seems that the job posting on data scientists are expecting everything. So what they're saying is that, a data scientist must be expert in advanced statistics. He should be excellent in coding, excellent in algorithms, in writing code which is like production kind of ready code. Okay, like software engineers do. The data scientist should also be expert in computer vision and natural language processing, data structures, probably excellent at writing packages, a lot of exposure to big data, should have a PhD, should have publications and so on, right? This is what is happening out there. If you search for data scientist roles, or if you go and search for it on LinkedIn, you will see all of these things coming. And this would lead you to think, what is this? Does such a person even exist? Is there a person like this who can do all of these things? Right? All of this, I would say, is noise. Okay. I would want you to think back of the view I gave you earlier. I said that data science is about creating value from data. It is not about natural language processing. It is not about computer vision. It's about an API. It's about bringing value using data. Okay. All of this is noise. So what is a data scientist, right? A data scientist, the modern data scientist these days, is someone, and again, just notice all of these are very, very general things, okay? Is someone who is conversant with the modern tools of the trade, first of all. Of course, you have to be hands-on. You cannot be a philosopher data scientist, okay? You have to be hands-on. So you have to know what the tools are. And whatever the tool is, okay, I come to those tools, but Python, R, or whatever, you need to have the tools. Second, you need to be comfortable working with large volume of data. You've already seen from the internet minute picture that volumes of data are tremendous. Okay. And you also need to work with messy data because most data now is unstructured, may not be very right. If you're analyzing tweets, you'll see the kind of stuff we have on tweets. Okay. Finally, the data person should be application focused, solving problems in that domain. And for this, they need to have good domain understanding as well. All right. So the data scientist, again, just to reiterate, the person is solving problems using data, guys. The person is not, his main skill is not coding. The main skill should be solving things, solving problems. It is not coding. Okay. That's what I want to you guys to think about. Okay. This is the thing. Work with large data, messy data, have basic hands-on comfort and focus on the applications part. Right. And I'll just show you. This I have to be very brief actually. I don't think we have time to go into details, but There are many roles in data science right now. Titles are very misleading. And one of the biggest reasons these titles are misleading is that even companies don't know what they want. Someone just tells them that you need to have a data scientist who will come in and magically use all your text data and data to give you some business profitability of 10%, I don't know, increased profit or something. It doesn't work that way. There's a lot of noise in the market right now, and titles are very misleading. But broadly, there are four kinds of roles which are there right now, and maybe sometime later we can discuss this in details. But there is one side which is the business analyst part, which is more around, uh, which is looking at the data, understanding the business very well. Can you recommend something to the business? Okay, so business, or maybe looking at the product, looking at the application, maybe, right? How people are interacting with the application, how people are clicking, where they're clicking, and so on. You tell them, maybe this works better, it doesn't work better. Okay, that is one kind of, which is very business oriented. Then there is something called a data analyst, which is more about, let's say, the data needs of the organization, which is important. How do I store data? How do I have data in the best possible format, which is very easy for analysis? Right? Maybe I'll create a nice dashboard. Maybe I'll create backend systems for those dashboards and so on. Then there is a data scientist, which again is a very vague term, but I just want to separate. This is that guy who is now, let's say, working very in depth. Okay, he's not really linked, not very close to the business side of things, but it's more on the algo part. He's not looking at macro things. He's probably focused on solving a problem using a model. Okay, maybe something of that sort. And then there is a data engineer. There's an ML engineer. ML engineer is, what kind of a role is it? I don't even know. This poor chap is supposed to do everything. Data ingest, data plus the modeling plus productionization of things and so on. Okay, but this is more on the engineering, more on the coding side of things. No, but maybe sometime later we can discuss all of these. But the skills and competencies for these roles are varying. Okay, a business analyst needs to interact with business, needs to be good at presentation, whereas an ML engineer may not do presentations. Okay? He'll probably be, his skill will be maybe scalable coding, whereas a business analyst may not really care about coding so much. He'll just do basic coding. So different roles, different kind of competencies. But what I want to talk to you about are the top skills. Okay, what I want to tell you is that even though there are different kinds of roles, and even though you read online that every data scientist needs deep learning, needs this, needs image processing, needs algebra and whatnot, and needs Kafka, streaming, so many things, that's not really the case. Just to bring in more perspective, there are some general skills which are critical, which everybody should have, regardless of what role, whether you want to become a data analyst or scientist or business analyst. There are certain skills which everyone needs. Then there are very specific or role, which are specific to the role or the industry, and there are niche skills. And there are some skills which are in between. Okay? So first, the general critical skills which all of you should have if you're looking to have a career in data. You should have comfort with SQL. This is like a must. Every company is now using SQL. Okay, if not SQL, they have Hive or whatever, which is now again very similar to SQL. So SQL is like a must now, mandatory thing for everyone. You should have comfort with at least one of Python or R. It doesn't matter which one really. Python is more popular now, so maybe you can go with Python. But both of them actually are very prominent, and it doesn't really matter which tool. It just matters that you are able to do things with one tool. Then communication skills. Okay, this is important. This is for some reason people don't talk of it enough. Communication skills. You'll either work with businesses, or you'll work with engineers, or you'll work with other people. Right? You have to have good communication skills, especially for the people who are on the business analytics side. It becomes a very critical skill, especially if you want to grow. And basic stats. Basic stats, I mean comfort with numbers. What is the mean, what is the average, how does the average help, what is standard deviation, variance, and so on, right? How these things work, what is the distribution, and so on. These are like critical things for everyone, regardless of the kind of role you want to get into, whether it's a business analyst or a data scientist. Then you have something in between. Now, deep learning, a few years back, this was not the case. That deep learning became that a skill most people need to know, or a large number of people need to know. What is happening now? Because the way you've seen the kind of data we have, there's a lot of unstructured data we have now, and many companies are using text and images and whatnot. Now, if you have to work with unstructured data, deep learning hands down will give you better performance in any classical approaches. So the volume of the type of data necessitates that deep learning is also something which many people start adopting. It right now at the moment it is not like a deal breaker that you will not get a data role if you have deep learning, if you don't have deep learning, but soon it will be in a position where deep learning will also become a critical skill. This is something you have to start also evaluating, but don't have to be experts really, but you have to have an overview at least. And then you have industry specific or role specific things, like some maybe Power BI. Someone says you have to have good understanding of Spark. Someone says AWS or Azure and so on, or Hive and so on, a big data role. But these of course will be very specific to industry and role. But the general ones, SQL, Python, and basic stats, all of you should have. And with standard machine learning as well as deep learning, you should also have exposure to them, even if you're not experts. Okay, right? So I think that's most of the stuff I had. I'll summarize. I think we have just 3 minutes, so I'll just summarize this quickly. So first point we are making here is the big picture now. We are drowning in data. We are starving for knowledge. And the most important part of data science is the application. You want to use data to create impact. Data science is that art and science. It is not about algos. It is about using data to create impact. Also, we saw that it is across domains. There is no domain where data science is not used. It is about solving business problem is the key part. And most business problems don't really need a deep learning model. It can be solved without a model as well. But you should be ready to do that if it requires. And then there are various roles in data science. The data scientist is a very vague term, but data science is welcoming. And the skills needed are not really the very high-end skills. Anyone can start learning Python. Anyone can start learning SQL, basic stats, and you can aim entering that domain. Okay? And with that, we have a couple of minutes. Happy to take any questions. Ismail has a question. I'm a commerce student. Can I get into data science? Ismail, so my point here is that anyone can, but you have to think carefully, make a plan for yourself as to what you want to get into, okay, or what kind of role you want to get into. Regardless of the kind of role you want to get into, basic stuff, do a Python, start coding. So basic coding. Don't have to be like extensive coding, okay? Basic coding, data manipulation, okay, you said business analyst, okay? So data manipulation, data visualization using Python is good. Or any tool you want to, it doesn't matter. And then SQL, make sure SQL. Once you know these things very well, it should be much easier to get into. Right. Okay, so yeah, we have less than a minute, guys. This is. I think there's no other questions, but just to briefly, right before we go away, I don't think we'll be connecting again, or let me know. But the key idea is, some basic skills you need to start learning, and you should be able to, in time, get into a data science role, which, by the way, is not just modeling. You can become a business analyst also, and you can still be in a data science profession.